Alright, so this is going to be a video on implicit differentiation. Now, you might not know what this means, but we have definitely worked with the opposite of what implicit of implicit, which is explicit. And it's called explicit form. It's basically the function y expressed explicitly in terms of x. So in this case, there's a y on one side and the x's are on the other. Okay? Now, you can use this to figure out the derivative, which we've been doing. So if you do derivative of both sides with respect to x, you'll end up with dy over dx is equal to, you should know this is going to be the derivative with respect to x of x to the negative 1 power. Using the power rule, you can bring the power down and you end up with negative x to the negative 2, which could of course simplify to negative 1 over x squared. So that is what you guys are used to, the explicit form of finding the derivative. Here is the implicit form, which is the opposite of explicit. Now the x and the y's are on the same side. So what you could do here is you could solve for y. That would make your life easier, but for the sake of this example, I'm going to show you how to do this implicitly. Same rule applies. You take the derivative of both sides with respect to x. So you end up d over dx of xy equals d over dx of 1. Okay, this side simplifies pretty easily because the derivative of a constant is always 0 because it's constant, it's not changing. Here, you're going to have to use the derivative of a product, which you're going to have to use the product rule for derivatives, which in this case, it would be f times g prime. So here's f, this would represent the f, times g prime, which would be dy over dx, plus f prime, which would be 1, because its derivative of x is 1, times g, which is y. So f is x times g prime, which is just the y with taking the derivative with respect to x. So I'm just going to write dy over dx. Plus, now it's going to be dx, or it's going to be the f prime, which is going to be dx over dx, which is 1, times our g function, which in this case is the y. So you end up with x times dx plus y. So let me simplify this real quick. Plus y is equal to 0. We still haven't solved for the dy dx like we did over here. So I'm going to do that now. I'm going to subtract y from both sides, and you end up with negative y here is equal to x times dy over dx. Divide both sides by x, and you end up with dy over dx is equal to negative y over x. Now, your answer is in terms of y and x here, but if you substituted the y as 1 over x, you would still get the same answer of negative 1 over x squared. So this proves that implicit differentiation does work for the explicit and the implicit. You'll still get the same answer. Now, you might think, wow, this is a lot more steps than just doing it explicitly. However, if you have a problem like this, it's much, much easier to do it implicitly than explicitly. And I'm going to show you how to do this problem in particular using implicit differentiation. Same rules apply. We're going to take the derivative with respect to x of both sides. Okay? Now, if you remember our derivative rules with a sum rule, you can just take the derivative of each of the things that you're adding. So I'm just going to break this down, simplify it a little bit easier. Okay, we run into a little bit of a problem here because we just have the y squared by itself. So you're going to need the chain rule to solve for this. So what we're going to do is we're going to need the d over dy times dy over dx, and then the 3y squared would go in right here. So using the chain rule, these would cancel, and you'd still have the d of 3y squared over dx right here. But you can't differentiate unless you have it the same variable. So here we have y, here we have y. So now we know the derivative of 3y squared with respect to y would just be, you could just use the power rule, and it would be 6y times, bring down the dy dx, and that's how you solve 3y squared implicitly. Then we're going to add this to the derivative of xy with respect to x. Again, you would have to use the product rule for this one, and you would end up with x times dy dx plus y times 1 because the derivative of x is 1. So that simplifies like that. The derivative of 3x with respect to x would just be 3, and the derivative of 2 with respect to x would be 0 because it's a constant. So let's further simplify this. We have x dy over dx plus y is equal to 3. Now we still want to solve for this term right here. So using our algebra skills, it shouldn't be too hard. We're going to first get rid of this y, so you'll end up with 3 minus y on this side. And then we're going to factor out the dy dx. Next, we need to divide both sides by the 6y plus x. Then you end up getting the dy over dx to be equal to 3 minus y divided by this 6y plus x. So that's how you do an example of implicit differentiation. If you have any questions about this, let me know.